Hi guys, today we're going to have a look at some forces problems. So starting off, a wooden block of mass 0.6 kg is on a rough horizontal surface. A force of 12 newtons is applied to the block and it accelerates at a rate of 4 meters per second squared. So this is important, a rough horizontal surface, and basically that's telling us that there's a force going backwards. I am going to call it F and then little f for friction. Now, we know the net force is going to equal F equals ma. Now the mass is 0.6 and the acceleration is 4, so the net force is equal to 2.4 newtons. Now, the net force, basically 12 is our force going forwards, minus our frictional force is going to equal 2.4 newtons. So if we just rearrange this, we're going to get 12 minus 2.4 is equal to our frictional force. 12 minus 2.4 is equal to 9.6 newtons, which is B. Okay, a ruler of length 0.3 meters is pivoted at its center. Equal and opposite forces of magnitude 2 newtons are applied to the end of the ruler, and this creates a couple as shown. What's the magnitude of the torque of the couple on the ruler when it's in the position shown? Well, to work out the torque of the couple, we use Fs, but we can't use the 0.3 because that is not the direct distance between the two forces. We need to use this distance here. So now we've got a triangle here. We know this is 1.5 meters here. We want to work out what's this length here. Well, we've got our hypotenuse, okay, and we've got our opposite angle. We've got our 50 degrees here, and we know this is 0.15 meters. We need to find this here. So sine theta is equal to the opposite over the hypotenuse. So we want to find out what the opposite is. We're going to do sine theta times by the hypotenuse. So sine of 50 multiplied by 0.15, we get 0.11 meters. Now remember, this is 0.11 here, so it's not the total length, so we need to double this length. Okay, so if we double it, I've got a few more significant figures on my calculator. If we double it, we're going to get 0.23 meters. So this is our S. So 2 times 0.23, okay, we get 0.46 Newton meters, which is C. Okay, the diagram shows 4 forces applied to a circular object. Which of the following best describes the resultant force and the resultant torque of the object? Well, we've got an overall force of 40 newtons this way. Okay, so the resultant force is not going to be 0. Also, this 30 newtons here and this 30 newtons here are going to act as a couple to try and rotate the object. So again, the resultant torque is not going to be 0, so therefore the answer is D. Okay, number 4. A balloon is acted upon by 3 forces: weight, upthrust, and a sideways force due to the wind, as shown in the diagram. What is the vertical component of the resultant force on the balloon? Well, the sideways force is only acting in the horizontal, so largely we can ignore it. We just want to look at the upthrust and the weight. Well, upthrust is 10,000, the weight is 9,000, so the difference between the two is going to be our resultant. So 10,000 minus 9,000 is 1,000 newtons, which is B. A uniform beam of weight 50 newtons is 3 meters long and is supported by a pivot situated 1 meter from one end with a load of weight W is hung from that end. The beam is in equilibrium as shown in the diagram. So because it's in equilibrium, we know that the clockwise and anti-clockwise moments are equal. Now the centre of mass of this beam is going to be halfway along, which is going to be at the 1.5 meter mark. That means that distance from there to there is 0.5 meters. Now the force down here is 50 newtons, so by applying the anti-clockwise and clockwise moments, we've got W times by 1 is equal to 0.5 times by 50. Okay, well, the ones, we don't need to really worry about this one. So 0.5 times by 50 is 25. Divide the 1, we find it's 25 newtons, which is A. Okay, an L-shaped rigid lever is pivoted at point P, which is just there. 3 forces act on the lever as shown in the diagram. What's the magnitude of the resultant moment of these forces about point P? Well, this here is going to cause a clockwise rotation. This force here is going to cause an anti-clockwise rotation, and so is this force here. Now, what we first need to do is, let's have a look at these different forces. Let's have a look at the one on the very end. So, its perpendicular distance from the pivot here is here. It's going in this direction. So we're going to have 2 times 10, which is going to give us 20 Newton meters, and then that's going around anti-clockwise. Okay, here, the distance here, well, if we've got 4 meters going out, 3 plus 1, and then 2 meters going back, this must be 2 meters here. 2 meters times by 5 is 10 Newton meters. Again, that's going on in this direction. And finally, we've got 3 times by 20, so we've got this distance here. 3 times by 20 is 60 Newton meters. Okay, and that's going around clockwise. So going around clockwise, we've got 60 Newton meters. Okay, then minus 20 minus 10, because the 10 and the 20 are both acting counterclockwise. That leaves us with 30 Newton meters, which is answer A. Okay, in this question, the diagram shows 3 forces that act on a body. In which diagram is the body in equilibrium? Well, for this we need to look at the arrows, and when a body is in equilibrium, the vectors will, by the tip to tail method, they should lead us back to the beginning. Now I'm going to start off, I'm going to say the answer is D. And why is it D? Well, starting off here, go here. From that tip to that tail we end up back here, and then from here we end up right back where we started. That's the sign of when a body is in equilibrium. A rigid uniform bar of length 2.4 meters is pivoted horizontally at the midpoint. Weights are hung from 2 points of the bar as shown in the diagram. To maintain the horizontal equilibrium, a couple is applied to the bar. What is the torque and direction of this couple? So what we need to do is have a look and try and work out what's the overall moment around the beam, and then the couple is going to have to be in the opposite direction to keep this thing balanced. So here, going around anti-clockwise, we've got 200 newtons times by a distance of 0.8, which is 160 Newton meters. Okay, and then going the other direction, well, we need to work out what's this distance here. Now we're told the length of the bar is 2.4, and if it's pivoted right at the midpoint, so 2.4 divided by 2 is 1.2. So the distance here to the midpoint from this 300 newtons is going to be 1.2 minus 0.8, which is 0.4 meters. So this length here is 0.4 meters. So going on this way, we've got 300 times by 0.4. Which is 120 Newton meters. So we've got 160 going counterclockwise and 120 newtons going clockwise. So the beam itself is going to have a moment of 40 Newton meters, and this is going to be going anti-clockwise. So for it to balance, we're going to have to apply a torque going in the other direction, which is clockwise. So therefore the answer must be A. Which of the following pairs of forces acting on the circular object consists as a couple? Now a couple is when you've got two forces that act anti-parallel and they've got the same magnitude. So firstly, can't be B, because F and 2F are different magnitudes, likewise with C. And also D here, F is acting in this direction and then this F is acting in this direction. So therefore A is the only couple that we have.